on team tomorrow. To get make sure Pratik joins that. So both of you otherwise are with clear.
I think you'll have to listen.
Okay.
Okay. So, okay.
Okay.
So our topic was LLM generalization on the silence.
Yeah.
Actually, I was the one who only did this paper. He was a bit busy. So the paper we read was Unibias, Unveiling and Mitigating LLM Bias Through Internal Manipulation. So this is our paper overview. So prompt readiness in LLMs. So what happens is that when we input any prompts into LLMs, the recently viewed one inputs, like say, if what's the capital of Italy, and if I say what's the capital of Belgium, and after that, if I again ask what's the capital of Italy, there is a chance that capital of Belgium might also have a high probability of happening. So because of prompt readiness. So that is one of the things that happen from LLMs. After that, the limitations of existing methods to prevent, to counteract those prompt readiness, we primarily focus on external adjustments, such as calibrating output probability. So if when we are testing the model and if there is a wrong output, then we put such counterweights externally to counter affect that. But what we want is that this method will actually use an internal level architecture to balance out that thing. And the internal sources of bias specifically occurs due to FFNs and attention heads, which we'll go into in depth as we move forward. And by identifying and understanding these bias components, we can directly intervene and mitigate their influence. So, so the unibias method is, so it is an inference only approach. It doesn't do much calculations. There are only six calculations that will come ahead. So this approach will enhance the robustness because it has just six levels of calculation. There is not much mathematical throughput that it will be requiring. To identify the bias components, it will actually focus on the identifying and utilizing bias attention sets and FFN networks that disproportionately influence model towards certain labels regardless of the input context. So there are three main problems. That is the vanilla bias. The vanilla bias, recency bias, and the selection bias that are in this problem. And this will identify all those types of bias components and help them mitigate it. So the criteria of identification, it is biased if it consistently attributes to specific label predictions across diverse inputs, indicating a lack of predictability. So we keep running it on multiple data sets, and if it happens that a particular type of is constantly being delivered on different data sets, then we'll say that that particular attribute is causing a bias in that. The logic lens technique is logic is the output which is unnormalized. So this logic lens technology will essentially technique will use internal activation in the capillary space. And it will allow for interpretable analysis of each component's influence on output flow. And to mitigate, once we bias these, unit bias will mitigate their effect by masking level. So instead of changing the weight, it will put an OR type function which will mask it over them and it will remove their contribution into model's decision making process. So causing the bias, so one of the focus is only on decoder only language models in this paper. which are composed of transform layers. The residual stream will transform each layer adds information from the fast forward neural network via the residual connections. So, and after that, it goes to the attention head. The output of each attention layer is transformer of its attention heads computed by applying separate projection matrices. And that formula for that projection matrix. So this was the mathematical part of this. Biasing FFN networks, how do we identify it? So there are to compare relatedness, we compute the G vector, which is G vectors what is the projection along the embedded vector space, and this is the label coefficients space. And we take the dot product of all three of them, and to compare relatedness, we compare over all classes and all labels. We take the dot product of them and normalize it with their respective probability. So this will help how correlated the classes are with each of the labels. So this is relatedness. Bias will take the this is not mod, this is just a simple bracket. It will subtract from this label logic the mean values, and then it will compute the, it is sort of like standard deviation sort of formula. But instead of directly using standard deviation, we are not summing it over just a particular label or class. We are convoluting it over the class and labels. So that is what this is essentially like convolution of the labels and over the class, where each is differentiated by the GJK function, which is the label logic and the average of that particular label. And we have the variance function, which is the standard deviation upon the mean. And now, how do we identify if the bias from FFN is biased? So, an FFN vector is biased if it exhibits high relatedness. That means a particular label is continuously occurring in that class. It means if a user prompts the chat box or some other thing, then it has a very high tendency of giving that output because of high relatedness to the input that we are providing. And high bias. Since in any LLM, we prefer low bias and high variance, the high bias automatically is a problem for us. And a low coefficient of variation, so we desire high variation. Relate to the input, like
It's supposed to be confident about the bias, high bias rules. I see. And this has been across all instances.
Yes.
Propensities towards while maintaining a low coefficient of variation. Again, variation across all instances.
Yes, because each instance, that is each label entries. Now we'll go into biased attention heads. So they are projected into the vocabulary space using the unembedded matrix and labeled token matrix. And their formula is over here. Each element A of the capital A is made up of small a's. So each AK is actually a dot product of the attention head hidden states, which is the convolution layers, the weights over there. So this H matrix corresponding to each label dot product with the unembedding matrix. Since we are going into the CNNs, we have to unembed the weights. So this is the dot E, which will do the unembedding. And we will do the label token mapping. So that for each label, what is the token that it corresponds to? So this each AK is the label logic value is done using this mathematical formula. And we have over all the particular P samples and classes, we create this matrix of R M cross C dimension. After this, when is it biased? So again, the same formula thing will occur, just like how over here relatedness, bias, and low variance was used. Over here, this will show the relatedness, and this threshold is the found iteratively. And that I'll show that it is derived by a grid search method. And this is again the mean method, and this is the deviation. But this time in standard, the variance part, here we didn't have any W vector being multiplied. Here we are multiplying with weights because attention, this has also a W H That is the attention hidden states over here. So we have to normalize it. So we need to multiply W transpose sort of thing. So that is why we have to multiply it by WJ again over your base. And after this, the function again criteria is that these two should be higher and this should be lower. And how are the thresholds found for all these three? For this one and as well as for these three thresholds are found using the grid search method. So grid search method, say there are 6 parameters, then there will be a 6 range values over here. So in our particular method, how do we rectify these biases? We perform grid using a support set of 20 samples per class. So each class has 20 samples, and depending on the number of classes, like some cases the number of classes were pretty. Okay, the number of classes are not over here, but the number of classes are pretty high, and for those, each class we have 20 samples. And we minimize the bias, the average table logics via grid search method. And it is found that we try many combinations, and in this result, people they tried up from 5.
It's not really grid search.
Randomized search.
Instead of that, also have Pareto frontier. So ultimately, if you plot the bias against, I think bias rates and other
Bias are relativities.
it is supposed to be high. If you draw, you draw so identify that there's some kind of a frontier.
Yeah.
And then there's a tipping point. Instead of we have grid search. So grid search, you'll need some label data for it.
Yeah, but that is why we need 20 samples.
But you could just identify the frontier itself. On the frontier, bias, the variance will start increasing.
This is what also in this also it happens that between 2 to 50, it is at a point 20 that it is occurring. It is hitting a point of saturation because above 20 there is no advantage there. So even I thought that there is a similarity between that and plotting a bias variance curve, but they somehow still focused on using such method. And after many combinations, the result is well in just a few unique sets of bias components. So just like I said, 80 combination might yield only 4 distinct biases. It is similar to the plot there. And the 3 kinds of bias are vanilla level bias, recency, and selection bias. So vanilla level bias means something that occurs more commonly is outputted by the chat box more often. Recency bias means the bias that has recently been, like the output that has recently been given. It is has a tendency of using that data to give out the another output. And selection bias is somewhat a mix of both of these. And we evaluated, this paper was evaluated on Gamma 2 7 billion model on our data set, which contained 4 options A, B, C, D. And so the data sets, they did 3 data sets: reasoning, natural language inference, sentiment classification, SST2, SST5, MR, and all this. And baselines, they had 4 baselines: ICL, contextual, domain context, and prototypical calibration. Evaluation strategy was simple. They used logic lens propagation for interpretability, and this simulated prompt brittleness through example reordering, prompt formatting. They used to give different prompts to see if the output of this method is perfect or not. And they even replace samples iteratively to find whether it was correct. And there are the main results I have formulated in for a few questions. So the first question we might ask is that after eliminating bias components from LLMs, does the in-contextual learning performance improve compared to original LLMs? So the answer through the data over here, it is that the proposed unibias method consistently achieves highest accuracy in use cases. And in terms of average accuracy, it is by a margin of 3.3%. If we were to compare unibias and ICL, it is more than 3, and over here it is around 2. So whether it is a Llama 13B or a 7B, it is achieving a higher performance, which means that it is a better version. Second thing is, after eliminating the bias components, does the ICL improve performance compared to the original one? Given that ICL suffers from prompt brittleness, can a unibias method contribute to more robust ICL? So how will we get more robust? So we simulate these brittle scenarios by choosing different demonstration samples, different prompt formats. So with unibias, the standard ICL's performance varies significantly. So as the problem was that on different prompts, the user was getting different types of output, which was a variation of 26%, which is pretty large. Using this unibias, we are achieving perturbation of around 4%, which is a pretty good range of chill. And due to recency bias, we place a negative sentiment analysis at the end of each prompt. And so this makes the LLMs tend to predict negative and incorrectly classifying positive samples. And this is something that occurs in ICL because they use biases outside the model. So as a result, if there's something wrong, they'll put a counterweight outside. But unibias will put it inside the CNN itself. So as a result, it will not always perpetuate that errors throughout the form. So that is why there is a much difference in their performance. And the support side on performance. So as you were saying, 55 to 50 samples is the what they averaged it out, and they found it that it was more than enough to have 20 classes per samples per class. And over there itself on GPT-J and GPT-2 XL, they found that they had a pretty high accuracy over SST2 and SST2. And the method that they used was unibias. So in each case, the unibias had relative high performance compared to the other ones. Yes.
It's an optimization process. Well, how you think you could pose an optimization problem? This is very heuristic.
Yeah. So the optimizing.
So then, I believe I only one people.
Actually, I was the only one.
In present, present,
Like actually, we agreed to like I was presenting the first half, but he continued.
and I understand. So both, you're saying both of them.
I did only one paper.
Sorry.
I was the one who read the entire.
Okay, present.
Yeah, but I went through that after that.
I didn't know this is goldfish loss, but the goldfish loss was dropping, say, K classes, say 25%. So it was very safe. So those two paper, I thought that that was a pretty basic one. So, because that one is it is published. It was the first paper that ma'am had on. So, no, like on the same. The spreadsheet, the first time you issued, right? The doc.
Okay, first finish this. Yeah, I will big data.
Okay, now the test code that we tried. Yeah, we were testing the code. The problem that occurred with us is that when we tried to run it, it's like the versions are not compatible. So on the GitHub code that we went, and even and I went to Medium as well to find out what.
It's a very interesting problem. No, it's a it's actually
ये इसमें पता नहीं उन्होंने करके रखा था हाँ उन्होंने जो है एक्चुअली कंप्यूटर इन्वायरमेंट जो है 4 NVIDIA A5000 that wasn't actually given. It was just it just said that grid search it takes two values, two ranges, and it will form a sort of combinations of all those values. It's set to integer steps, like if you take the same. Yes. They did give it in the code, but I was not able to understand their code much. I searched on Geeks for Geeks, and the definition I said was that it means that say there is a particular grid, and you have to search for a particular point. Then you will keep on searching for entirely. You searching for the entire area that will come up. For the model, it will try every combination that will
If I'm searching where
the weights, like say if there is a particular
wait. You should, I mean, you have given the literal meaning of this.
Yeah, exactly. What is the steps like? What is the grammar?
Search is to give the hyperparameters and threshold in. You haven't mentioned that. Even if not written in the paper. I mean, I'm sure if they have written on the research paper, how come one research be published without it?
it actually they just this is what they have written. It's such.
All the combinations of what? You can see the second line. Can you read them?
We then did search Usman all combination of threshold values and select the combination that results in most balanced distribution of average layers. The average layer threshold.
No, I'm not average label logics. Select combinations of threshold values. Select search all combinations of threshold values. You have to understand the set there.
So actually, I would say
No, but see, this is one paper you have done, right? You should read it properly. I mean, you should. This is not so difficult. Direct search all combination possible. Yes, all tuples of threshold. Select the combination or the permutation that results in the most balanced system. How do they distribute? I mean, is it to entropy balance? How do they measure the balance? You don't know. You have to take some problem.
actually, sir, I'm an electrical and we had DDL labs. Good. So,
Everyone had this.
yeah, so that is
the second.
yes, so that is I wasn't able to manage. Yes,
You actually take more time. The ideas will learn faster. You learn the topic much better, and you're from optimization very also. Research that is root force even there. Anyways, so specifically like T represents the set of thresholds for combination and PT average label logic threshold combination. P aim to find a combination piece down that minimizes the bias of label methods. If this bias is as they are present. Can you please get to the core of it for the project?
in this, what they have done, they have taken a data set from and they have just learned it and done over it. What we want to do is say we want to put it in a real life chat box and put that inside. And when we talk with the chat box, that is the goal of the project. To implement the chat box. Yeah.
I would say
Actually, this.
Just doing more intelligent search would be an interesting problem. First, understanding itself, baselining it, and then seeing how, for example, you can interpolate nicely. Can you discuss with that? But presently, I mean, understand the problem presently. What is the other thing? Don't take the time.
No, just a moment.
You have to open this.
Can you show what
This one.
which one?
I was talking about this over here.
This issue is open. So,
This one. Acha, in this.
Think about the data.
Acha, okay.
What do you-
Yeah, so over here they are using this method. That is, they will say suppose there are 100 tokens that they are training for a particular model. Then in this, what their aim is that with what 1/k probability, where k is a chosen type of parameter, they will drop those k% subsets. And then they'll train on that, say 1 minus 1 by k. They'll drop tokens, train the model on those 1 minus 1 by k remaining tokens, and then that 1 by k tokens will be used as test data during the training itself. Like it won't be training data, the 1 by k will be.
So random.
Yes.
Scale.
Yes. In which prediction is calculated. It is a pseudo random method because say first 13 are dropped. After that, those 13 won't be dropped in the next one. It will be such that the ones which were previous to them will be dropped and those 13 will be included in that. Sort of. It is iteratively taking some k and not including them in the sequential. They would just verbatim give that out, but over here they will change this out. Like, and okay, so they train the model on the Harry Potter text, and after that they ask a particular question. So on 100 documents that were pertaining to Harry Potter, Wikipedia documents that were pertaining to Harry Potter, and they ask a particular question. Same this guy, Mr. Dudley, etc.
The first started with
So in this, it's Harry Potter, and this there are 100 Wikipedia. No, they are different things.
What was so simple about it? It's like there was
The idea of implementing is comparatively simple. That they are dropping pseudo-random subsets of size k, and then they are training the model on those remaining, and using those k drop one as test validation.
some parameter search. Drop tokens. What did they drop tokens for?
They
It's
use
just evaluation. But for some, there's a difference between private key. Then you have movements. So the goldfish loss of its subset thus prevents the model from learning the entire token for a chosen goldfish mass. Goldfish loss. It was just select basically the gating. Please like gating.
that is what I was trying to say, that they choose a particular number as
Yes. Specification. Given passive, the model does not have a vertical. So it has never conditioned the exact sequence of this time. So ice drop.
This is for one iteration. After that, when there is second iteration, it won't drop those. It will include those k. It will drop another some other k, and none of those previous ones. Like they are not used. They are used in another training. Like if there are 100.
So it's just like some Like dropout? I mean, is it just like dropout?
Yeah, a particular fraction is dropped out. That is what I was able to understand in basis of how they did this.
We need a little bit effort. So we sure that if it's what is your project name?
So our project proposal is to include that this unibias into a working chat box. This time, this wasn't on a chat box. It was just on a particular training data set that they had. Now this time we wanted to implement it on a real-time chat box like LLM may do, like which uses LLM and we do. We wanted to use it on the chat box.
But you should bring a little bit of optimization perspective. Yes, fine. It's an optimization course.
So I think like while integrating and as well as the suggestions which you gave to remove bit search.
Okay. Shape or real.
That is
You see that.
actually, ma'am, I've been pretty busy for past 2-3 months.
See,
It's my mistakes.
you and you're yeah, as you were talking about. I'm great. For seminar, but you're not present with you. But I assume it's only yours. Subhashnu. The project, are you going to contribute seriously? Yeah. So for seminar, you're not getting this. I mean, there's nothing you're presenting, right? So it's having this again. I'm assuming it's only Subhashnu.
If you have contacted me, we can discuss if we.
Yeah.
want to use that. Okay.
So
Okay, I'll talk to you.
I assume subsequently. Take your project seriously.
Oh, here, man, this LLM generalization.